Welcome to The Explainer. Today, we are tackling a huge issue for anyone building with AI: the runaway cost of retrieval augmented generation. RAG systems. If you've ever built one, you know exactly how powerful they are, but you also know how fast those token costs can just spiral out of control. But what if I told you that you could slash those costs by as much as 70%? In this explainer, we're going to walk through a really practical blueprint that can turn an expensive prototype into a system that's ready for production, and more importantly, a system that's actually profitable. And I'm not talking theory here. These are techniques that deliver real, measurable savings. And the difference this makes? It's absolutely staggering. Just think about it for a second. A basic, off-the-shelf RAG can easily burn through over 5,000 tokens for a single query. But an optimized one, like the one we're going to lay out today, can get you the same or even better results using less than 1,500. So yeah, this is the journey we're going on, from a money pit to a cost-effective powerhouse. All right, so here's our game plan. First, we're going to look at the high cost of context. Then we'll get into how to stop wasting tokens early. After that, we'll cover squeezing with re-ranking, and then we'll get really clever with smart routing and caching. And finally, we'll put it all together in the 70% savings blueprint. Let's dive in. Okay, first things first, we really need to pinpoint exactly where all this cost is coming from. I mean, why does a seemingly simple RAG setup end up being so darn expensive? Well, the answer lies in one word: context. So here's the brutal truth. Most of the token waste isn't because the final model is expensive. It's because, well, we're being a little lazy. We're sending way too much unfiltered, irrelevant information to the most expensive part of the whole system. We're using a sledgehammer, our biggest, priciest LLM, for every single task, and we just keep recomputing answers to questions we've already seen. And this right here, this perfectly captures the problem. We're basically just shoveling massive amounts of raw data into the system, and with every single piece of that data, money is just leaking out. I mean, even a small number of retrieved documents can add up to thousands of tokens, which, at scale, creates a total budget disaster. So the most crucial point is that our first, and maybe our most important opportunity to save money is right at the very beginning. I'm talking before we even perform a vector search. We have to shrink the haystack before we even start looking for the needle. So how do we actually do that? Well, it's this beautifully simple two-step process. First, as you're adding documents into your knowledge base, you enrich them with metadata. Just think of them as smart tags. Is this document about product X? Is it from Q4 2023? Then, when a query comes in, you use those tags to filter your entire database down to a much smaller, way more relevant search space. You're not searching everything anymore, you're just searching the right things. And this one little change has a massive ripple effect. Seriously, it's not just about saving money on tokens. You get better, more relevant answers because you've cut out all the noise. You can enforce security rules by filtering based on user access levels. Oh, and your whole system gets faster because it's searching through way less data. It's a win-win-win. Okay, so we filtered our search space. That's a great start. But our next step, re-ranking, is where we go from casting a wide net to using surgical precision. After our initial retrieval, we've got a list of potential documents. Now we need to find the ones that are actually useful. This quote right here, it just nails it. High recall without re-ranking is a token disaster. It perfectly sums up the biggest mistake developers make, treating retrieval like it's a one-shot deal. The pro move is a two-stage approach: retrieve and then refine. Just grabbing a big pile of documents and hoping the answer's in there somewhere, that's not a strategy. That's just setting money on fire. So this is the core of the strategy. You start by casting a wide net, but cheaply, retrieving maybe 30 to 50 candidate chunks. Then you bring in a specialist, a cross-encoder model. Now, unlike a standard vector search, this model looks at the query and each chunk together, scoring how truly relevant they are to each other. From that scored list, you have to be ruthless. You keep only the top 3 to 5. That's it. And the impact? Just look at this. It's staggering. We're cutting the number of tokens we send downstream by way more than half. This single step is one of the biggest levers you can possibly pull for cost reduction. It's such a simple change with a massive, massive financial impact. And you know what? We can squeeze even further with something called context compression. Before we send those final chunks to our expensive model, we use a smaller, cheaper model to do one last cleanup. It acts like a little editor, pulling out only the most relevant sentences and creating a tight, focused summary. This can shave off another pretty significant chunk of tokens, driving our costs down even more. Okay, we've already made some huge progress. But now we get really smart by stopping unnecessary work altogether. This is where routing and caching come into play. The big idea here is to stop using your most expensive, most powerful LLM for every simple task. It's like using a Formula One car to go grocery shopping. It's just overkill. Instead, you put a small, fast router model right at the front. It looks at the incoming query and decides, is this a simple FAQ or is it a complex reasoning problem? Based on that, it routes the query to the cheapest model that can get the job done. In a lot of systems, 40 to 60% of queries don't even need the big model at all. And check this out. In most production systems, a huge portion of the queries, sometimes up to 40%, are just repeats. Now, a simple cache isn't going to work here, but a semantic cache, that's a game changer. It understands that how does your refund policy work means the exact same thing as explain refunds, and it can serve up that saved answer instantly for zero, that's right, zero LLM cost. All right, so let's put all of these pieces together. Let's take a look at the full architecture that combines all of these techniques into one single, highly cost-optimized RAG pipeline. And here it is, the full blueprint. A query comes in, and first we check the cache. Is there anything there? No? Okay, it goes to our smart router. The router points it in the right direction, and we apply our metadata folders to shrink that search space. Then we retrieve broadly, re-rank aggressively, and compress the context tightly. Before, and only then, do we let it anywhere near our expensive final model. The difference is it's stark. A basic pipeline is a straight, expensive line right to your most valuable resource. The optimized pipeline, on the other hand, has all these different gates and checkpoints. It treats the large LLM as a final resort, something to be called upon only when it is absolutely necessary and with the most pristine, relevant context you can possibly give it. Look, if you walk away with anything from this, it should be these 4 techniques. These are the heavy hitters. If you properly implement just these 4 ideas, aggressive re-ranking, context compression, semantic caching, and model routing, a 60 to 80% reduction in your token costs isn't just possible, it's realistic. So the final takeaway is this. Controlling your RAG costs isn't about sacrificing the quality of your answers. Not at all. It's about being smarter, being more deliberate, and more efficient at every single step of the pipeline. It's about building systems that are not just powerful, but also profitable and sustainable at scale.